it has valency 6 and it forms these molecules with this kind of.
Buckminster Fuller.
No, Buckminster Fuller is more like football and things like that. So very simple. Very simple atom which not like carbon has 4, something has 6, and it actually forms exactly this. And the symmetry is very important because of spectroscopy. So when you try to understand the structure of an atom, of a molecule, you can't see it, right? So what you do is you have to understand it by the kind of light it scatters. And when structure has symmetry, that affects the kind of light it scatters. And
Benzene
is what? Benzene is carbon and hydrogen is a hexagon. It's a flat hexagon. So it's no, I'm talking of an atom, not a molecule, which has exactly 6. You can put 6 anions to it. So just look it up. Yeah. So I forgot it.
The applications you need asking.
Huh.
I have a feeling that in real life you always have a combination, not exactly.
Exactly. Yeah. So this is more like real life. But the symmetry of this is exactly the same as the symmetry of the decahedron and the icosahedron. Okay, so
if you give a little bit of allowance for other shapes also in the mixer type vectors, like molecules, probably we have many.
but shapes of molecules are quite perfect. I mean that's the thing. I mean it's not an approximation. It may be enriched in certain ways. And when you study crystals, then you have larger arrays. These are just finite objects. You have repetitive patterns of these things, and then the symmetry manifests itself in the spectrum. So this is one of the main applications of representation theory to chemistry is spectroscopy. So there are in fact this was one of the things in the early days of representation theory. Spectroscopy was one of the reasons for trying to understand the characters of the symmetry groups. Of course, the Plato did not need any applications. We study them because they are there. These are 5 perfect things in 3 dimensions.
Sir, if we construct some building using this shape, whether it is stable?
Stability.
That's a good question. So if you construct, so what you can do is you can try making these models and try squeezing them and see. No, I'm serious. You try making these models. You can make these models with matchsticks and this valve tube. When your bicycle slowly air is coming out, then you take it and that guy will pull out one black thing and put a new one. So that valve tube you can buy it very cheap in a cycle shop. Maybe 15 rupees for a long piece of valve tube, and using matchsticks and valve tubes you can actually make very nice models of these things.
Yes, made.
And you made it. So Arvind Gupta has a website.
Yes.
Then you make the model and try squeezing it, and you will have the answer to your architectural question as well. You can also try to look for buildings which have these things.
Has
So
anyone done research about the rigidity of this?
yeah, of course, yeah. So
I think the science at the Sabha, you have distributed the body decahedron.
yeah.
I put on the program.
Yeah.
It was a souvenir.
Yeah, so
That
it has exactly 12 faces, so you can put 12 months on this and make a calendar. But whether it would be rigid if you just had the beams along the edges or not is an interesting question. So I think you should look at it. Okay, so
And Sir C.V. Raman, he speaks about the association between prime numbers and the leaves or petals of the plants. Have you come across that?
No, I don't know
When you take a petal, it has got 5 petals or 7. You take
Usually there is a
Yes, sir.
correspondence between Fibonacci numbers and
Yes. I actually
I've heard about this corresponding with Fibonacci numbers, but again I think one should go out and look at the plants and check.
Yes. Now I came across some 20 years back. I can't get the book. I want to get it reminded from through.
So, but C.V. Raman was in spectroscopy, so crystal
He
spectroscopy.
speaks about this the vegetation and other things. You find some association between the petals or the leaves of the trees or the plants and prime numbers.
Okay,
I
don't know
tested
about
it actually. Also, cactus.
Okay, so yeah, but I'm only yeah.
Your website, sir, website, sir.
Yeah, it's Institute of Mathematical Sciences. You'll find it. So, yeah.
Sir, what
Yeah.
is your opinion on the mathematical realism or the numbers are real?
I believe mathematics is an experimental science. That these things actually exist and we try to study them.
Mother of all sciences.
Sir, already Ramakrishna was there.
Yeah, yeah. No, there are people who believe that it's a creation of the mind. So,
There is also that Kepler had done some interconnection between these solids and the others.
was that Kepler or was it before that the Greeks? They couldn't understand how the planets move, so they came up with some theory that yeah, Aristotle. So it was the ancient Greeks. On the other hand, the ancient Indians were the best at predicting the positions of the planets. But that is one of the things that drove the development of mathematics in India. For astrology, we wanted to predict where planets will be, and these are very difficult calculations. So now we don't look at the sky because there's too much light pollution. I feel very sad that the thing which inspired us to do mathematics is now not available to us.
Only in Chennai, not elsewhere, sir.
Everywhere now.
No, it is pollution, sir.
Yeah.
If you go 40 miles away, actually this afternoon
yeah.
you could have seen a great sight. The moon was visible. I could not actually remind you.
Last full moon,
Yes,
it was very
no,
bright.
no,
Yeah.
Moon is in the daytime. At
Oh.
12 o'clock the moon was visible. Or say daybreak. We call it. This is not my session. What we call this is daybreak. It's actually it is a grand sight. We really
What did you call
miss
it?
seeing moon
Uh-huh.
in the daytime. Descending. Yes, actually. What we call descending moon. We miss it actually.
Mhm.
Yes.
Yeah.
Yes, yes. Yes, and last of all, big moment, please. On behalf of